Alright, as promised, here's our extra practice for solving equations. This will be a great resource for make sure you're ready for your quiz. As like I said, it will lead you through some additional problems that we didn't cover in the previous notes. Alright, write down the first question. Solve the following equation. One of your goals when you go through this is looking at these, and before you even pick up your pencil, decide what am I going to do? What method am I going to use to solve this? Okay, so hopefully you look at 81 and 1/3 and realize that you can rewrite these with the same basis. So this is an example of a same base question. Same base question. So I'm going to rewrite these with both with a base of 3. So 81, I'm going to rewrite that as 3 to the 4th, and I already had that 3 minus x, equals 1/3, I'm going to rewrite it as 3 to the negative 1 times my 5x minus 6. So since my bases are equal, now I can set my exponents equal. So I've got 4 times 3 minus x is equal to negative 1 times 5x minus 6. And I'm solving for x. Alright, so let's distribute the 4. 12 minus 4x, distribute the 4, is equal to negative 5x plus 6. Alright, solving for x. So I'm going to add 5x, and I'm going to subtract 12. So I get x is equal to negative 6. So negative 6 is my solution. Alright, let's try another one. Alright, take a moment and write down this problem. Alright, like I said, if you want a moment to try to solve it before I work it through, please pause the video. Alright, think it through. Let's see. I see a log. That means I may end up with an extraneous solution. So I wanted to find my domain first. So that means that 4x plus 3 has to be greater than 0. So solve for x here. So x is going to have to be greater than negative 3/4. Alright, log equation. So I want to isolate the log expression and then change the form. Alright, so it's already isolated, so all I need to do is change the form. So 6 to the second power is equal to 4x plus 3. We're going to solve for x. So 36 is equal to 4x plus 3. Subtract 3. 33 is equal to 4x. So x is equal to 33/4. Alright, check that against my domain. Well, it's positive, so that means it's definitely greater than negative 3/4, so it's okay. So my solution is 33/4. Alright, try another one. Write that problem down. Here again, if you want, as I said, try it before you see me work it through, then please pause the video. Alright, we see a log, so that means we may have extraneous solutions. So that means x minus 9 has to be greater than 0. So x has to be greater than 9. And I have another log, so x has to be greater than 0. So x has to be greater than 9 and greater than 0. Has to meet both conditions. Okay, so I've got two logs. I want to condense them and put them back together. So I'm going to use the multiplication property to put these things back together. So I'm going to rewrite this as log base 6 of x times x minus 9 is equal to 2. Alright, now I want to change the form. So 6 squared is equal to x times x minus 9. I'm going to solve for x. So 6 squared is 36. Distribute my x. Alright, it's a quadratic, so I need everything on one side. Let's factor. So what multiplies to give you negative 36, but has a difference of negative 9. So it would be negative 12 and 3. The lead coefficient is 1, so that means I can go x minus 12, x plus 3 equals 0. Use the zero product property, set each x equal to 0, or each factor equal to 0. So x equals 12, and x equals negative 3. All right, check for extraneous. 12. 12 is greater than 9, so that one's good. Of course, it's also greater than 0. So 12 works. How about negative 3? Well, negative 3 is not greater than 9, is not greater than 0, so that means that one's extraneous. So my only solution for this is 12. So we did end up with an extraneous solution. Okay. And here's worked out again. All right, let's try the next question. Write that one down. Pause the video, like I said, if you want to work it out on your own first. All right, what do you think? What do you see? What are we going to do? Well, hopefully you recognize that 100 and 1,000 can be rewritten with the same base of 10. So this is the same base question. All right, so we're going to do the following. It's the same base. Set the exponents equal. Distribute my 2 to get 14x plus 2. Distribute the 3 to get 9x minus 6. And then we're going to solve for x. So you're going to end up with 5x equals negative 8. So x is equal to negative 8/5. All right. We haven't had one that looks like the following question yet. Try that one. Write that one down. Here again, our base is e. So the bases are already equal to each other. So what do we have to do? Hopefully you set the exponents equal. And you'd be right. So we're going to set the exponents equal and just solve for x. So we end up with 2x equals 10. So x is equal to 5. So remember, e is a number, right? So treat it the same base question. Almost too easy to be true. All right. Here's another problem. Write that one down. All right, what's happening here? Well, 3 and 12 we can't rewrite with the same base. So if we can't rewrite with the same base, what's our next step? Hopefully you said change the form. And that's exactly what I did. All right, so let's change the form. So we're going to make this log base 3 of 12 is equal to 4x. Well, this is an easy one. We need to solve for x, so all I'm going to do is divide by 4. So x is equal to log base 3 of 12 over 4. Now that's the exact answer. We could put this in the calculator and get an approximation. So our approximate answer, let's see, we got log base 3 of 12 over 4. So 0.565. So approximately 0.565. Don't forget to write that 0 placeholder, right? SOL. We don't want to miss it because we forget a 0. All right, another practice question. What are you going to do? Well, hopefully you said this is a change the form question. So we're going to change it to logarithmic form. So log base 4 of 12 is equal to 2x plus 3. Solve for x. So log base 4 of 12 minus 3 equals to 2x. Divide by 2. So x is equal to log base 4 of 12 minus 3 all over 2. So that would be the exact answer. And here again, you can put it in the calculator. See, I've got there's my decimal approximation. Alright, but remember that we can't leave it like that. We got to go, let's see, negative 0.604. Okay. Alright, another practice question.